All right, let's dive into something pretty fascinating today. We're going to pull back the curtain on the hidden world of industrial machinery and decode a secret language, a language that massive, powerful machines are speaking all the time, one that can actually help us predict the future. I mean, just imagine this for a second. Think about a giant power turbine or a pump that's absolutely critical for a factory. What if, instead of just, suddenly failing and causing total chaos, it could give you a clear heads up, days, or maybe even weeks in advance? Well, believe it or not, this isn't science fiction. It's totally real. See, every machine has a hum, a shake, a vibration. And hidden inside that vibration is a story about its health, its stress, and what's coming next. We just have to know how to listen. Okay, so let's really get into this. Why is this little unseen shake so important? Well, because in the world of heavy-duty machinery, a surprise failure isn't just a small problem. It can be an absolute catastrophe. Think about it, right? Production just grinds to a halt. Costs for repairs go through the roof, and in the worst cases, it creates some really serious safety risks. So preventing this chaos, that's the #1 goal for any maintenance team. And the key to doing that is all about listening. And that's exactly where vibration analysis comes in. It's basically the science of translating all those shakes and shudders into actual, hard data. By measuring vibrations, usually at key spots like the bearings, we can give a machine a really precise checkup without ever having to take it apart. But, just listening isn't quite enough. If everyone's describing a vibration in their own way, the data is pretty much useless. What we really need is a universal translator, a common standard so that everyone can understand what these machines are actually saying. And that's the real challenge here. Without some kind of shared language, an engineer in Germany and a technician in Japan would have no way to agree if a machine's vibration level is perfectly fine or a terrifying sign of impending doom. And that language, well, it's called ISO 10816. It's this internationally agreed upon set of rules that gives us super clear guidelines for how to measure vibration and, this is the most important part, how to interpret what those measurements actually mean for a machine's health. It's kind of like the Rosetta Stone for mechanical vibration. Okay, now this is where the standard gets really, really smart. It takes all this incredibly complex vibration data and boils it down into 4 simple, easy-to-understand zones. The best way to think about it is like a traffic light for your machine. Zone A, that's green. Everything's running perfectly. Zone B is also good, kind of like a solid green, totally fine for long-term use. Zone C, now that's your yellow light. The machine is still running, but it's not a situation you want long-term. It's a clear signal to schedule some maintenance. And Zone D, oh yeah, that's the big red light. Stop. The vibration levels are now high enough to actually cause damage, and you need to take action right away. And see, that's the real power of this whole thing. This system turns vibration data from just a bunch of numbers into a clear, actionable tool for making decisions. Is it in Zone A or Zone D? The answer tells you exactly what you need to do next. No guesswork. But here's the thing, this isn't some one-size-fits-all standard. Not at all. The real genius of ISO 10816 is just how versatile it is. It actually has different parts that are tailored for specific types of machinery. I mean, just look at this range. Part 2 is for those massive steam turbines you see in power plants. Part 4 is for gas turbines. Part 7 covers the kind of industrial pumps you'd find in just about any factory. And there's even Part 21, designed specifically for modern wind turbines. Each part sets different thresholds that are customized for that exact machine's design and all the stresses it goes through. So, the very same framework that helps keep a city's power grid stable is also being used to check the health of a pretty common, much smaller industrial pump. This incredible ability to scale from the absolutely massive to the everyday, well, that's what makes the standard so powerful and why it's used everywhere. All right, so we have the problem, these unexpected failures, and we have the solution, this common language for vibration. But what's the bottom line? What's the real-world payoff here? The impact is huge. It's a revolutionary shift in how we manage these critical machines. We're talking about preventing those nightmare, catastrophic failures that can shut down entire plants, saving companies millions. It slashes that costly, unscheduled downtime. It extends the life of the equipment, and it makes workplaces so much safer. And that common language, it just makes everything more efficient, driving down maintenance costs across the board. And that's really the big idea here. You stop waiting around for things to break and then scrambling to fix them. That's being reactive.
Instead, you use data to predict when they might break, and you step in before they do. That's being proactive, that's predictive maintenance, and it's just a smarter, safer, and way more efficient way to work.
So, in the end, we've learned how to translate the secret language of machines, turning what used to be silent warnings into real, concrete actions. It's incredible, right? And it leaves us with a really fascinating question. Now that our technology is getting even better at listening, what other secrets are our machines just waiting to tell us?